Welcome, everybody. I'm glad you're able to join us today. I think we have another really important webinar to share with you. This one's about next-gen project delivery, understanding and leveraging push and pull, and the flow control of production systems. So a little bit of background on what we do as the joint working group out of the Construction Industry Institute. Have a lot of members that are interested in where we take this next generation of project delivery that combines the likes of AWP, advanced work packaging, the lean construction component out of LCI, and also project production management with PPI. So all have contributed to what we believe is an effective production system in delivering our projects much more effectively. So today we have myself and John Strickland. We are the co-chair of the joint working group. It is open to members. As you can see, our email addresses there. So if this is something of interest to you and you'd like to contribute and be part of this, you're certainly welcome to join. So before we introduce all the panelists, I will like to at least say a few words about how important I believe push-pull is in any system, any project delivery and project management, construction management program. And so push and pull, as listed in the as I mentioned in the description of the work, I think are the fundamental elements of any control system, any activity, whether you're passing one activity complete to the next activity, or there's a demand to complete something at a certain time. Those are the keys to how well our projects flow and how synchronous our projects are and how collaborative we can be in terms of all our project systems and our team members, our stakeholders that are all involved with each of our projects, from the corporate level all the way down to the foremen and executors of the actual production system. So with that, I'm going to first hand it over to say a few words to Dr. Chu. James, you want to say a few things, especially why you believe this is important?
Sure. Thank you, Fernando. Thanks for everyone for attending. I'm the technical committee member at the PPI, Project Production Institute. The reason we believe this is important is that PPI, we view projects as collections of which means they can be designed and controlled, as we do with any production facilities we build. The push-pull that we're discussing today are the most well-known control protocol that determine how these production systems behave. When we say behave, it means how much money they will cost, how long it will take, how much money will be tied up. Therefore, it is critical that we understand what these terms mean and how we use them. So therefore, we believe it's pretty important.
All right, thank you. So next, Nick Wan, our project execution advisor from Chevron. Nick, say a few words about why you think it's important.
Yeah, sure. So Nick Wan, project execution advisor with Chevron, just means I get to go around and help all of our major capital projects in execution to deliver on the promises that they're making. And one of the things that we are kind of laser focused on in Chevron is trying to make sure that our projects are predictable, safe and predictable. We focus a lot on costs and schedule and stuff, but we're not really even looking at this point to try to figure out how to reduce costs and schedule so much as just be predictable on the ones that we've agreed to already. And so we see push and pull, what we've learned from this specific topic, these particular topics is being instrumental in being able to achieve predictability. And so that's generally where my interest lies.
All right, thank you, Nick. Okay, Sean Greystone, Director of Lean Coach over at Fluor. Introduce yourself and say a few words of why you think it's important.
Thank you, Fernando. Thank you, everybody, for tuning in and watching. I think my key interest in this came from a conversation with John and Fernando, which had to do with the fact that as more and more sophisticated understanding happens, as the knowledge is being spread, we all believe, I hope I'm speaking on behalf of everyone, that there's a lot of confusion out there about what does pull mean, what does push mean, what is its real applications in lean. Some people think push is bad and pull is good. With all of the, and everybody thinks they're right, which is another issue here. So we just thought it would be helpful because we all do believe that these issues are at the core of the management of high performance production systems and systems management, that it would be helpful to just have a general conversation about all of this. That's really the main reason. I mean, there's a lot to understanding what variation and variability mean and do, and how to mitigate, and how actually to pull the best results and create just what I think Nick said. It's reliability. A lot of this boils down to the issue of creating reliability in flow. So that's my reason. I think I want to start.
Thank you, Sean. And then John, my co-chair, why don't you say a few words?
Sure. John Strickland, Collaborative Flow, spent many years as a project manager, construction manager, operations manager for large projects. And I recognized early on the flow was critically important. Then I started to understand more and more that we don't understand it. And I think that we're going to cover some concepts today that aren't part of the everyday conversation. And I think if we do this, we can not only make the projects a lot more predictable, we can get rid of a lot of futile hurry and a lot of unnecessary stress on both the systems and the people that are in them. So I think this is a way to make not only our projects better, but our lives better. And I think that's the next slide, Fernando. I think we talked about a little bit what the whole joint working group's trying to do. And this is about developing better understanding. This whole effort and the whole series of webinars we've done and the whole series of papers we've produced is about taking the perspectives of at least these three organizations and understanding better what it is they're trying to tell us. As we get a better understanding, we'll develop better project leaders, some of whom I hope are on the call today, and that's what's going to lead to better projects. And with that, I think now we can actually get into the actual meat of the conversation here of just what are we talking about?
Yeah, so here's what we expect to be covering today, and we're always looking to get feedback from our audience. So why are push, pull, and flow important is the key one. Basic concepts and definitions will be covered. The concepts of work in process and how that is either enhanced or harmed by lack of a push-pull or any kind of flow strategy. Variation, uncertainty, and buffers that impact this. Then we'll cover some key points and common misperceptions at the end, and then of course what we want our audience takeaways, and comments, and then we'll figure out next steps. So part of that, the key part of this session is, hey, what do you hear us saying? And do you have similar or contrasting examples? And so we'd like to hear these takeaways from you as we go through this, or questions that you may have. And we'd like you to participate interactively using the questions feature. So you can all enter questions, individually. So if you have a takeaway that you think is important, or if you have a question that needs to be addressed, please use that function.
Yeah, we're going to reference those later in the program, so that'll help us out a lot if you give us some material.
Right, exactly. Okay, so with that, let's. What is all this push, this pull, and why does it matter? So I'm going to hand this over to James Chu, and he'll take us through a little bit of the science of it.
Okay, let's go to the next one. So Sean actually hinted to this, and most of us here, at least have at least 2 to 3 decades of experience trying to actually work with push and pull. And as Sean said, there's a lot of confusion out there, and we hear these are a few of the common ones that we hear. That push is command and control. It's pushing, forcing people to do more than they can. Push is bad. Pull is good. It's making to actual demand, making to order. It's collaborative. It doesn't work when system has variation and so forth. And that's because there is many definitions, even according to the dictionary. If you go to the next slide, if you pull out the Webster dictionary, here you can actually take a look, and if you actually use Oxford dictionary, you might actually get different definitions. So there, even the word push and pull by its definition has many variations. But what we're going to focus on today is what does push and pull mean from a production perspective. Okay. So that is what our focus actually is today. So what do we mean by production? All of us that's involved in a project, one form or another, work in designing something, making something, either in factories or fabrication shops, delivering something using these mechanisms, machines, and installing something out in the field with labor, equipment, commissioning, startup, wherever it might be, okay? Or any of the supply flows that affect these flows. So the question is, because these are actions that take an input and produces an output, that using these labor, equipment, and space, these are production systems. It just happens to be linked with each other. So Fernando, do you mind pressing another button? If you do so, what you're going to see is that these are things that are going to move across, whether it could be a single piece of pipe that gets engineered, fabricated, delivered, installed. It could be IWPs that gets created, fabricated, delivered, and installed, and tested, commissioned and tested and commissioned. So these are things that are moving through the system. How and when these things move is the conversation today, which is the push, pull, and CONWIP. The concepts are fairly simple, right? Push means there is an external demand, and that triggers, the keyword is trigger, which is same as control. It triggers the start of the fabrication, and the rate in which it gets fabricated will get pushed to determines the rate in which it will be delivered. It will determine the rate of installation. Pull, on the other hand, says this triangle has a specific amount of inventory. And when that inventory starts to get taken out, the amount of items gets taken out of the inventory, it triggers to fulfill that inventory to a certain level. And we're going to take a look at what its relationship is with Kanban systems that everyone talks about in the Toyota production system, right? In the Toyota production system. But at the end of the day, pull has a specific amount of inventory that the work is getting pulled from, and then it triggers a replenishment. That's a pull system. CONWIP system actually says, okay, rather than triggering at each point in the production, why don't we trigger the beginning when something comes out of the overall system. CONWIP stands for constant work in process. And it's a methodology that was developed by factory physics, which I also represent. Okay? So in that world, the benefit is you're controlling the amount of work in process while minimizing the amount of communication that has to occur between each operations, which means the fabricate, deliver, and install. Okay? So from a pictorial perspective, these are pretty simple concepts. The comparisons, again, push, the work is released by external factors. Pull, the amount of work in subsequent operation or stock point determines whether you should do the work or not. And CONWIP is determined by the amount of work in the system. And in terms of work in process, push, because it is being released at a certain rate. If work starts to build up because one of the downstream activities is not able to keep up, you're going to actually see an increase in work in process. Whereas in pull, there is a limitation in each operation and stock point. Therefore, the whole point of pull is to ensure that the WIP does not grow. And CONWIP, it's set within the operations, the process across the operations and queues. So total amount of WIP in the system remains constant. So from the actual definition perspective, push, pull, and CONWIP are pretty simple, right?
So James, maybe I can jump in here for just a second.
Absolutely.
Okay, so a couple of things on push, pull, and then the other term that I heard John use earlier was around flow. This is a term I've learned quite a bit from our lean consultants, and so it's not necessarily a term that we use a lot in construction in the industrial engineering space, but I think we get the idea, right? That the idea is you have uninterrupted flow. And it's a bit aspirational, but there's, the analogy that we can use certainly in the oil and gas world is we understand flow quite well. We have product flowing through pipes all hours of the day. And we certainly understand the objective to make sure that that flow goes uninterrupted safely and uninterrupted, right? And so to do that, we use control valves. This could be analogous to some of the Kanban systems that we talk about in a pull system. We use tanks as buffers, and so we understand the concept very well. The other thing that I find is certainly in our core business, the use of tanks specifically, for example, is a buffer, which I know you're going to talk about a little bit later. There's this, we understand the cost and the benefit of those, right? Ideally, we're using tanks to ensure we can go through some sort of equipment upset or chemical delivery delay or something like that. We use inventory for that purpose. And so operations and engineering will typically try to lean on that to smooth out operations as much as possible. But then on the business side, certainly on the finance side, we understand there's a cost to that inventory. And so there's this natural tension to try to maximize productivity in our operations while minimizing the amount of inventory. Inventory sits on the left side of the balance sheet, but it's unmonetized value. There are costs and risks associated with inventory. And so we have a real healthy understanding of that tension, and we wind up, successful companies tend to operate lean, right? They tend to intentionally, in some intentionality with respect to those two concepts. On the construction side of our business, maybe is where I see the difference. We will oftentimes lean heavily on those buffers and on that WIP, the inventory that you're talking about, and we don't necessarily have the same balance, and I find, right? So we've studied a lot of these systems in our company, and we often find that we have excess WIP in our processes, and so it's an indication that we aren't quite as balanced, right? So if I hear folks, especially if they're in leadership positions, say things like, I'd rather be looking at it than looking for it, or we're, as an owner, we're not in the construction business, we're in the storage business. These are all, kind of, red flags to me that these are projects that might not be as efficient as they could be. So anyway, maybe there's a parallel or analogy that might be helpful to some folks.
Yeah, thank you, Nick. Yeah, I think one of the key takeaways here, and I think James started out that with the definitions. In the lean world, sometimes you hear the word push and you think it's bad, or you hear the word pull and you think it's good. And the fact is that each contributes to a very efficient production system. So if I push something, it's how much was that expected to be received, right? If I keep fragmenting things and say, here's what I got done, take it from here, right? That kind of gives us a little indicator of that the system may not be working. I'm saying, here's exactly what you did, your turn, you're the handoff, basically like a track, right? In a relay race, we're handing off the baton, and it's exactly when and how it needed to be handed off. So I think stressing that both are good, right, when used well, and that if you don't use them correctly, they could also harm the production system. So James, I don't know if you have any comment about that, but I think we're going to move on to
Fernando real quickly. I'm just going to insert a couple of things. Eventually, as we discuss all these things, what we're really talking about, as we said at the very beginning, is predictability and reliability and outcomes, right? So as we talk about push, talk about pull, we talk about flow. Again, variation here is kind of going to be key to almost all of the elements. It touches on everything here. And I just want to point out, James and Nick are both talking about physical systems here. And now when we're looking at projects and we push this into the project world, we push this into the execution side of production, there's something to remember here. Systems and the mechanics of pushing and pulling things through systems are far more reliable than the human factors involved. Being the lean coach of this group specifically, once again, I want to emphasize that the human factor changes a lot of things and creates a whole bunch of the variation here that we're talking about. So we can try and mitigate and ameliorate variation, but once we involve human beings in the production flow of things, things become a little bit more complex. So projects should be those highly complex systems. The other thing is to re-emphasize really Fernando's point and what we said at the beginning. Push isn't bad and pull isn't good. As a matter of fact, they each have their place within production systems. And if we're talking about the mitigation of variation, we need to understand that push and pull each have their place. And the greatest understanding and takeaway I think that we can get from this is the fact that they need to be blended. The fact that they interact is actually very critical, and what we really need to know is where to push, where to pull, how to do both and do them correctly.
Yeah, and Sean, can you comment also on the fact that a production system is not necessarily out in the field, that we see production systems throughout, right? Engineering and so forth.
Yeah. No, this entire, I hate to use the word flow in the wrong context, but this applies to every element, particularly in the world of construction. Whether we are in conceptuals, whether we're in design, whether we're within the evaluation from the owner's point of view as to whether to, the go or no go question, all the way out to the end of the execution line. Fernando's point is rolling money, I think.
Yeah, and Nick is the owner. Go ahead.
No, but
yeah, I was going to say, and Nick is the owner, of course, that wants that predictability. All these things that are moving in real time, engineering, fabrication, are the key to predictable delivery. And how you can set that up from the owner's perspective, especially, right, will have a profound outcome on how these things actually work.
We've had a lot of. Go ahead.
Sean's point about people factor is very something that we actually really need to take in, because when we actually look at projects are a lot more human driven and people driven, and therefore the need for control is even greater than manufacturing.
Yeah.
Whereas manufacturing facilities that are hardware or equipment driven can be designed, and once it's properly designed and turned on, it operates within a certain parameter. Whereas people can actually make different decisions on a daily basis. And every hour, every minute, every second. So therefore, the actual control mechanism that support their decision making needs to be even further defined and even better designed, right? And even that goes into engineering, fabrication, delivery, installation, every aspect.
Yeah.
James'
Which leads us into your next.
Yeah, we'll get there immediately. But James, your comment reminds me of how Greg Howell defined what projects in construction are, which are networks of reliable commitments, not of reliable manufacturing. So, I mean, it really is. That adds the complexity to this, that it creates a whole different need for analysis.
Good
As I
point.
said, it's not rocket science. It's much more complex.
Yeah. To John's point, much more nuanced. Much more nuanced.
Yes.
Subtleties that are not always readily derivable.
Much more complex, but not complicated.
Yeah.
There you go. Okay. Any other comments before we move on to some of the guts here? So, what problem are these control protocols designed to address? So I'll hand this over back to James.
Yeah. So as we had already talked about it, hinted, any project that we work on, whether you're actually looking at an equipment, structural component, mechanical systems, or anything, right? Something actually has to be engineered. It has to be fabricated. It has to be delivered and gets installed. And once it's installed, you might actually have the first box of installation you see on the top might be your structural. The second box may be your mechanical. Third might be your instrumentation, right? So there are multiple flows of, as Nick introduced the word flow, most of the things that are actually flowing through the system. The question is, how do we configure this so it behaves the way we want it to behave? A lot of projects, there is underlying assumptions made, and we quietly see actually this, and we'll talk about it in the next slide. We either take the systems as given, and we can manipulate them or control them or entice them to behave the way we actually want it to behave, or we use other means to try to control them like contracts, right? So therefore, what we're trying to propose here is there is a science that we can use to design how we want the system to behave, and then put in the right control protocols and mechanisms so it behaves the way we want it to behave.
Yeah, I think
what
one of
else?
the key points,
What, John?
key points there, James, is the actual real projects have an absolutely almost infinite number of these supply chains, and everyone is trying to manage their own production system. The piping guy is trying to manage his piping production. The spool shop is trying to manage something else. And we need to get the various things linked in a system rather than everyone trying to protect and defend their own production systems and boundaries at the expense of other folks. And I think that's part of it. And then understanding the key variables you're going to show us here in a minute.
Yeah, and I just wanted to add to using this slide is if you look at anything that goes wrong in the production system, right? We don't get synchronized to get the reliability or that predictability. An engineering failure, may tend to delay fabrication or fragment what gets delivered at any one time, or the QA/QC is not right. Right? What happens out there is our fields can't get things get delayed, so this flow delays this flow. Or something gets started early and we start fragmenting, right? And then once we start fragmenting, we start losing little bits of control and to get our job done. So what can we do? And yes, things aren't going to be, we're not going to get everything perfect, but how do we manage this system so we get more and more reliability, in our site assembly process?
And John and Fernando are both speaking to one particular point where some of that disconnection that was just mentioned comes from where individual groups, and we talk about siloing all the time, try to maximize their own flow without regard to the system flow.
Mm-hmm.
And what we're talking about is system flow, how to manage this correctly as system flow.
Perfect.
And it gets back, we're going to actually talk about the implication a little bit later, but what's in it for each organization to do so, right?
Yes.
And so, for example, if you are, again, we're not speaking to everybody here, but one of the most common aspects that we've seen on a project is if you ask a fabricator to minimize their time, minimize their cost, maximize their productivity, one of the things that they try to do is to show themselves with a buffer of engineering drawings. How much engineering drawings? As much as you could get your hand on, right? Same thing goes for delivery. If you ask a logistics company to say, minimize your cost and improve your productivity, another most common way is to say, give me a lot of stuff so that I can maximize my bed truck space, my container space, whatever it might be, so you can actually fit the small ones with the large ones, so maximize the utilization of my logistics capacity. Again, same thing goes for installation. If you ask maximize your productivity, they might say, well, as long as I don't run out of material, as long as I don't run out of information, then I should be able to keep a good productivity. How much? I'd rather be looking at it and looking for it. I think Nick actually said that, right? We actually seen a point where it said they legitimized or they even made it a policy to have 3 months of material on hand for a $10 billion project. Now, you don't have to be a rocket scientist. John said it was harder, but you don't have to be a rocket scientist to figure out that is a lot of money tied up, and you probably don't run your household that way, right? And then go from installation to installation. If you ask the mechanical contractor to maximize their productivity, how much structural work do they need done before they show up? As much as they can get their hand done. We, in the building industry, used to say, give us a floor. If you give us a floor, we can run for the floor as quickly as possible, right? Now, this way of designing the production system may work for certain people. Again, if I'm a fabricator, I can say, give me 100% of the engineering documents. I don't want to see any changes. Once you give me the documents, they're locked and loaded. Any changes you make, we'll do it at the back end and we'll charge you for it. That may be the best way our production system is governed. But if you're someone that's interested in actually making sure that things flow through the system, I think that's a terminology we keep hearing today, right? Flow through the system and not get boxed in these cylinders we see, then there is an alternative way to look at this. And the question is, how do we make it flow? Again, that's what you want as an organization. Now, all we're saying, and Sean pointed to this already, we're not actually saying push is bad and pull is great. What we're saying is, are you using the right protocols to ensure the system behaves the way you want it to behave? Okay.
And to
Push,
emphasize,
pull, and CONWIP.
yeah, James, you're right on the point. As an alternative, this is just for an example of thinking on the deliver and install side. Some of the 2 points. One is communication and collaboration between the parties is critical to get to what James is talking about here. He just gave multiple examples of people maximizing a moment in the flow for their own benefit. There are rules on certain super high production construction sites where the flow for the entire system is moving better. And contrary to what James just said about delivering 3 months worth, there are some sites working and modifying flow amazingly for the larger project by the rule is deliver no more to the site than you can install in a 24-hour period and keep the flow constant. So just-in-time thinking applies here. I'm just trying to point out there's changes in the thinking that James just talked about, and they may not, they're actually counterintuitive sometimes.
Yeah, but picking up here, kind of quick summary is, if you want to optimize one piece of the system, you often do that by creating buffers to shield it. But when you add all those buffers up, they kill the flow through the system. So you got to decide what it is you're trying to optimize to get flow through. And most people are very, very good at seeking to create buffers to protect themselves, but they're not very good at thinking how the buffers they create for themselves affect somebody else. So that's, we can come a little by James's point about moving on about how do we choose which one to go with when.
Yeah, I was just going to add, this is exactly one of the things that we're working on in Chevron. We had convinced ourselves that if we optimize all of the individual pieces, we will optimize the whole. But what we've learned, as James is illustrating, but what we've learned over the past few years is that that's not actually the way it works. If you want to optimize the whole, that almost by definition means you will be sub-optimizing the individual pieces at different times. I came off of a project a couple of years ago where month after month after month, we would celebrate excellent productivity in engineering, but the project schedule would continue to slip and slip and slip. And so that was an example of optimizing, one piece without optimizing the whole. So go on, James.
Yeah, and you actually have a great point. We had worked with a company where the actual fabrication and installation was done by the same company, but because it was two different businesses, they were actually optimizing for individually. So what we saw is huge amount of inventory built up between the fabrication and construction, sucking the cash out of the company. Right?
It's almost like a guarantee,
same organization.
If you optimize each step, you're guaranteed to compromise the system unless it's a system with no variability. So anytime you take the reductions, the whole equal the sum of the parts, unless you're working on one of those magical projects with no uncertainty and no change, you're going to be short-sighted on the system side.
So the real question is, it's not a question about whether to pull or not to pull, whether to push. It's not the real question, right? The question is how to deliver the desired output, whatever that you're delivering, whether it's in a building, whether it's a facility, whether it's wells, whether it's a hospital. How do we actually deliver that with minimal working process and cycle time by controlling the working process at the optimal level? Why do we think controlling the work at the working process at the optimal level is important? Because there's a science that governs how this behaves. Can we go to the next one? So again, if you want to learn more about the details, these curves, at the end of this today's session, there is an educational sessions that you could attend to actually learn more. But just to point out a few things here. The one in the middle is that says, as the working process increases, the amount of throughput, i.e. the amount of cubic meter of concrete that you can actually install on a daily basis or weekly basis, inches of diameter pipe that you weld on a daily basis, weekly basis, whatever it might be, deteriorates as there is variability. But as you add more working process, the amount of incremental output that you're going to get is very, very little. However, if you look at the curve on the right, as the width goes up, the cycle time goes up. Okay, so the adage that we talk about in our industry, you can't finish something you haven't started. So let's actually open up work phases, get it going, is increasing the work in process. You may not get much more out, but what you're going to see is extended cycle time, i.e. amount of money tied up in your system, cash flow wise. Okay.
And I think
so,
we can, I was just saying, I think we can think of cycle time as kind of a proxy for flow, right? Increased cycle time is the opposite of flow.
Exactly,
Yeah,
exactly.
I like what Big. So if you're thinking about running your production system on projects and you're not thinking about cycle times, variation, utilization of WIP, it reminds me of an electrical utility company that doesn't understand Ohm's law. Okay, that there are principles that determine how much current gets through a conductor. Okay, and just adding more pressure, it does not get you to where you want to go. So this is what we're trying to bring the science so we can make it so much easier to make the workflow through our system.
Yeah, and Nick's comment actually brought something to mind. So a lot of projects that a lot of companies that we recently talked to are starting to talk about early project early warning indicators. Okay, how can I realize when my project is going to go off the rails before I get my report 2 months later? Okay, and one of the things that you can actually understand is if I make a change now, when we actually see the cycle, when we see the impact of that change is whatever your cycle time is. If it takes 6 months to get something through the system, then once you make a bad change today, we'll see 6 months later. Cycle time is a lagging indicator. Work in process is the leading indicator.
Yeah.
How much work in process you have now. So that's one of the key things that we're trying to make people assist people in understanding is we want to make sure we have the right amount of work in process because we will pay for it later if it's a bad decision.
Yeah, and I'll add to that, so we can make it real what our projects are looking like. So work in process is that we can't complete the work that we had planned all the time, right? So what happens is that we say, well, stop here, but I got to keep my people busy. So the key word is I got to open up more work fronts, right? Not on the plan or later in the plan. And so there's a lot of disruption. So the fact is that, hey, we're always opening up work fronts because we can't complete work. That's increasing the WIP, the work in process, and adding to the variability because now we got to sort out how are we going to go complete all these things as people move from one work front to another because they have to keep busy, right? So that's a reality on a lot of projects, and that's what we have to work towards.
Or even more basic. People think, hey, the faster I start, the faster I'll finish. Well, maybe not. Not if you're just starting and putting the work in a pile of WIP. You're not going to get done any faster. You're just going to create make your system much less flexible and make it slower. So we got actually we have several more slides to get through here. It's a pretty good conversation.
Yeah, and it would not do justice to not actually talk about Toyota production system, and we're going to actually tie this to lean, right? So it's worthwhile talking about. So when Nick and I actually had a chance to visit the Toyota production system, and we actually saw it in action. And one of the things that was very, very clear is these concepts in action. So if you actually, the facility that we visited, there was a car coming out, one car every minute, right? One truck every minute. And I think that's what a lot of people actually took the takt time, right? One car every minute. Every operation that was done to the car had to be done less than a minute. Otherwise, the car will not be flowing. So by definition, whether they're taking 30 seconds to do it, 45 seconds to do it, if you're taking 45 seconds to do it and the car's coming out every minute, your utilization is 75%. It's designed to be 75%. No one's walking up there saying, why aren't you guys working 100% of the time, right? Because it's trying to create a predictable output. At the same time, where the conveyor belt is moving at that speed, you see Kanban systems. So people are taking inventory and putting it on cars. And there's a bin with the parts that when that's doing it. As you have an empty bin, that bin goes back and it triggers a production of those parts. So you actually have a production Kanban as well as the condensed compound, which is the delivery compound. Each one has a specific amount of inventory that is designed to have in the system so that those things can match. Okay, so what the main line is absorbing the variability using extra capacity, which we'll call capacity buffer, and the pull system is actually dealing with the variability using the inventory buffer. Now, here's a concept of how this all ties together. For any variability that you have in the system, and it doesn't matter whether this variability comes from unforeseen, unknown, uncontrollable, or they come from 100% known, 100% purposefully designed variability. What is the designed variability? All the pipe sizes may be different. All the pile sizes might be different. All the concrete footing size might be different. Okay, those are something that we purposefully design in because the facility requires them. But what that does is the welding speed is going to be different. Duration is going to be different. Concrete placement duration is going to be different, right? And the way we transport might be different. So therefore, this is a variability that we design into the system, regardless of where it comes from. Production system does not know where it comes from. It only behaves based on the implication, which is we're going to need either capacity, inventory, and time to absorb it.
I love that.
Three types of buffers.
James, you're pointing out that you don't just remove the buffers. You don't just eliminate the inventory. You eliminate the variation that caused them, and then you can have less. You don't just take away the buffer. You take away why you needed the buffer.
Why? Because it's the second bar chart that shows if you take one away, the other one actually takes its place. So if you try to maximize utilization by taking the capacity buffer away, if someone actually says it's a lean system, so we should not have any buffers, so we actually any inventory, so we take away the inventory, time's going to take over. We're going to see things running late, and we go, that was unpredictable. No, it was 100% predictable because of the policies that we implemented. Okay. So the thing to actually think about is the production system is exactly behaving the way we designed it. We may not have done it purposefully. The only way to reduce capacity, inventory, time altogether is to reduce the total amount of variability. Okay?
Yeah.
So reduce the variability, reduce the buffers. That's what I think John's saying.
Which takes us right to one of the myths, and we may touch on this later, we may come back to it, but there are certain myths involved in this. And one is the fact that uninterrupted flow, perfect uninterrupted flow is achievable. It's not. And that variation can be controlled or eliminated, which it cannot be. Not, again, there are predictable variations which can be managed, as James was alluding to, pipe size and stuff. There are other variations that cannot be predicted, and buffers actually are just part of the amelioration and mitigation system as we constantly adjust to get as close as we possibly can to uninterrupted flow in the best manner possible, but they're ideals. They're not actually achievable physical states.
Yeah, and therefore, as you just put it, if there is not enough capacity buffer to absorb it or inventory buffer to absorb it, time will take its place and things will start running longer, right? But now, how do we make sure that we design the right amount of buffers into the right places so that we are able to deal with it? It's more robust systems, right?
Yeah. So there are lots of future events that we can neither predict nor control, and that they kind of manifest themselves in the variation. And so rather than have a production system that's very inflexible, that can't respond to the variations in what really happens, I think we need to find production systems that are responsive enough to absorb the variation that we can't get rid of.
Which emphasizes things like agility and thinking. It emphasizes the Einstein quote, what is it? Creativity or imagination is more powerful than intelligence, right? It's a variation of the often misquoted Darwin quote about the species that survives the best is the one that can adapt to change the most quickly. It's not the meanest, it's not the fiercest, it's not the most intelligent, it's not the strongest. So what the emphasis here becomes creative, flexible, agile, and I'm not talking about agile and software thing, I'm talking about agility in the ability to manage change and make the constant fine-tuning adjustments to the line at all times is what creates, or what helps us get closer to the creation of system flow.
And actually highly centralized systems, especially ones that I would call contract driven. I said, reality doesn't read your contract. It doesn't care what your terms and conditions are. Reality is so to deny reality is kind of a fool's errand. So our attempts to manage variation through contract management just create a buffer someplace else. As James said, when we try to protect ourselves there, we're just creating more buffer somewhere else. So we have a number of other comments here. We're actually running a little, we've had such good conversation. We're going a little longer on time. I'm curious if you want to kind of look at some of the takeaways we came up with so far about this whole thing in general.
Yeah, so one other thing to add, what traditionally looks, what it looks like on our projects, and you can go away and think about this. And it's stated earlier, for instance, inventory. We all want to control inventory because I'd rather see it than look for it, or trust the supply chain to deliver, which is a real issue. So hey, I want to control my own buffer on inventory. I want to control my own people on resources because I just want to have a balance, and they will march a certain way across the project, right? So we make these kind of assumptions that that's our resource buffer for people, or we only want one crane because more cranes are expensive, and so let's just use the one crane. Right, so we see all these things traditionally as buffers that are just planned in the work without even thinking about that, but mostly around cost, right? Time buffers. Hey, I want to say I'm going to take this long because I got a little bit of extra buffer in case I don't get done, or something surprises me, or there's an interface point that I didn't anticipate. Right, all these things are, to me, are traditional buffers that we tend to blend into our projects without understanding them.
Yeah, I think what someone actually alluded to earlier, if there's no variability, push system, pull system, and CONWIP system behave exactly the same way.
Right. It'll just happen the way you planned it out because it was perfect, and we know that isn't true.
And when we actually hear people actually say, I can't implement the pull system because of variability, hopefully we actually made a little bit of given a little bit of insight today. Pull was designed to deal with variability that push systems are not able to. So again, when you think about these opportunities, please actually look at it from, okay, how do I control that variability? Using what type of buffers, and what are the control protocols that we can implement to enable that? Right.
Well, that's the first of our key points there, James, is that this was something we kind of had to kind of wrap up there. The first one is, hey, if there's no variation, there's no need to worry about the distinction between these systems. And, the project with no variation is sort of like the Easter Bunny. I've heard about it. I've never actually seen it.
Yeah, and some of these are what we had hoped to have you come out of this, and there's a lot more. I think I believe John will look through them, but the fact is, optimizing flow involves countless semi-independent production flows, right? They all have to come together to look at a project, and controlling WIP is central to a well-designed production system. Pull-based systems such as pull planning, CONWIP, Kanban control system, do control the WIP, and proper use of push, pull, CONWIP signals are key enablers to that. Right, as long as they're organized and collaborated around. There will be key feature, there will be key future events, which John said earlier, that can either be predicted or controlled. Right, production in a system that's agile enough will allow for those variations to be absorbed and rapidly replanned. Right, contracts can't manage production. Right, they have the requirements, but it's the people, I think, that Sean and James alluded to earlier, that really are going to be the designers of the production system. So contracts have to have that built in. How well the system is designed will determine how well a production system responds. Use of buffers and controls. The need to avoid individual buffers at the expense of the system, right? That's key. We can't do one, suboptimize one at the expense of another. And I think also understanding that, reduce system risk holistically rather than just reassigning it, which is a lot of it. Hey, give it to some other guy, let them let them deal with that problem. And of course, that comes back in all sorts of pricing and claim schemes and all sorts of things
and many other horrible things too. I should say all of us have spent many hours discussing all this as we prepared for this, and that last point that Fernando alluded to came out of a comment that was made as part of lean thinking, which is in high performing lean collaborative environments, we reassign risk and risk parity. We don't assign blame, because again, this has to do with it was said at the beginning, optimize the whole and not the parts. It has to do with communication. It has to do with collaboration, understanding how the pieces fit in with one another, not whether one particular piece of that system is maximized or not. It's critical.
Which is kind of like the complete opposite of what most of us learned as project management theory, which is to protect your boundaries, focus on your scope. And let's see if we see the audience takeaway. Have we got any comments from the audience, Fernando?
Yes, we do actually. And I don't know if you were looking at them, but I'll read through some of them. And thank you for contributing. If you have some more, please add them to the list. But I'll start with Annabella Martin with Hilti. From an operational standpoint, who owns the responsibility for the creation of the production system data and interfaces at the project level? And what type of software or group of software does this information best compiled and managed through? So that's a question. And who has access to the system? Is there any specific industry stakeholders or construction industry sector that is doing this particularly well? So the responsibility for creating these production systems is really boils down, in my opinion, on how the owner is receptive to setting these up, right, and looking for these type of outcomes. I've seen it work well with some EPCs and general contractors that use this as a way to gain profit, which is fantastic. If you have your own system and you bring it and you can bring it in that way, great. But typically, the most successful projects are when the owner decides that this is enough. And I don't know, Nick, if you have anything you want to add to that.
Yeah, I was gonna say the same thing. Ultimately, the owner really owns the risk anyway, right? So it's in the owner's best interest to manage this. Yeah, I mean that's kind of my initial thought.
Yeah, and the second part of that is, go ahead.
From an implementation portion, who leads it is whoever is, I think, ready to lead it, because this is a little bit of a different paradigm. We actually see where engineering teams are bringing these concepts to the project, where the overall project actually is collaborating on it, whereas in fabricator actually bringing it. It doesn't really matter which company they're from. It is the desire to actually align the overall system to behave a certain way.
Right.
Yeah, most likely fabricators and contractors have their own, overall production systems that they're looking to manage, and this should fit into one project's production system.
Yeah.
I think we have to respect all those other production systems. I remember working with a piping contractor. We were trying to link it all up back in his production shop. Says, I don't want you in my production shop. I've got lots of other jobs there. And so, so part of that is respecting, where we do need to respect the nature. I like a phrase James used quite a while ago, that if you own the entire production system and there were no commercial boundaries, how would you want it to operate? So in other words, if you didn't think you could ship the waste to somebody else, would you act differently? And I think that's a good way to think about it. With 5 minutes left, Fernando, we got some other ones there. We want to let folks what to go do next.
Yeah. I think we'll definitely do that. I think there's definitely some takeaways about the production system. Seeing them as connected production systems for sure. That is one takeaway. Yeah, I like that. They're also designed variability. You usually don't see people doing this, and that's 100% true. There's some questions about the advanced work packaging. We'll send a follow-up.
Maybe I'll just add. Can I just add one thing on, because this is an AWP community? I would imagine there's quite a few. I think the path of construction is a step in the right direction here. I don't know that it goes quite far enough, but I think it is a step in, at least a step in the direction that recognizes that we need to focus on this thing from the back, from the right side to the left, right? And start to map out what that looks like. So it's maybe not quite all the way there when we talked about production systems, but it's at least a step in the right direction.
Yeah, no, for sure. So, and there's a lot of great comments here. You know, even how do you measure predictability, right? The Lean community has looked at plan percent complete, commitment liabilities. You know, there's a lot of leading and lagging indicators, as James indicated, to kind of give you an idea of how well things are happening. You know, how you break the projects down so they can be consumed by those that have to go execute the work, whether in engineering. So there's a lot of metrics and processes that go into the mix, and that's why it's a science, right? We don't let things ad hoc, we don't let one person command and control it, right? There's got to be this collaborative means. So it's the people, the process, the technology, you know, and ultimately the culture that has to kind of influence this. So I know that we're kind of coming up the last 3 minutes, so we'll get everything, and we will respond to a lot of these good questions here. But let's wow, there's a lot. Okay. So
Fernando,
so there
real
are
quickly,
some. Yeah, go ahead.
Fernando, I'm getting a couple of messages from some people who are watching. I'm actually getting them on my other computer, which is some people have trouble inserting stuff into the comments box. So there's a couple of questions. How do we educate owners better? Because this is such a radical change in systems. I would encourage everyone to, if you can't get into the comment box, because that's a valuable question. As you saw, Nick's nodding. I'm thinking the same thing. Please send it to one of the email addresses to any one of us, and we are going to compile this and put together answers, because I'm very encouraged by the amount of questions and comments that are coming in. So please don't hesitate to get them to us. Sorry, Fernando, I didn't want.
And we'll go through all these and be distributing out all the slides and everything. And there'll be a comment. The video will be available as well. So next gen webinars on the horizon. One of the key ones coming up here is about early applications on some key projects that are actually considered some of the benchmarks of the best projects in the world, and why did they work so well, and what can we learn, and why haven't we really repeated it, right? There's a lot of great things there, and that's going to be, if you're familiar with T5 at London Heathrow Airport, it's a classic one. And sometimes we just need to be reminded of how well that went. Application roadmap for blending lean thinking, ADP, and operation science. You know, that's going to be addressed. That seems to be the biggest, one of the biggest questions is how do we actually go move forward with this, and then managing the decisions process. So we have some great speakers coming up around that. I will also talk about conference events coming up. All right, so Safe Build Alliance, Respect for People is coming up May 2nd in Portland. So that's very much on the lean side, address the people opportunity. CII, as Jenny mentioned earlier, we've got a big conference in San Diego on the 30th and 31st. Construction contracting, August 28th and 29th. It's ECC in Colorado Springs. AWP conference, October 7th and 8th in Houston. The LCI main annual Congress is coming in October 22nd and 25th in San Diego. PPI second annual technical conferences on the 24th, and the 11th annual symposium on the 5th of December at Stanford University is also, that's a PPI event. And also I believe James has a couple here I want to go to.
Can you go to the couple afterwards?
Yeah. So there's papers out there. These are links to the papers that we've written on organizational culture, better together. There's the ADP plus lean, exploring better opportunities together, comparison of approaches, how they both can contribute to better project delivery. And one of the ones that we think is really nice is optimizing project workflow. So all the key things that contribute to workflow, and you know what we compared them to, and what should we do about it. All right, and also James, you want to talk a little bit about these?
Yeah, so there we at PPI we have a joint program with Texas A&M, and we have one coming up shortly in May 21st at in Houston about where we actually take these concepts that we talk about, you know, wider perspective, and you can actually learn about, who's actually doing this, how have they done it, and how do I actually leverage it. So if you want to, as Annabelle's question, I think it was Annabelle, I think, how do we actually educate the other people and owners? This might be a good opportunity. Okay. And we have again, a PPI, we actually have a commission paper that we republished, we printed with permission that answers this question if you want to further dive into it.
Excellent. Okay, and with that, if you want to learn more, here's our email addresses. You can reach out to myself or to John, and we're happy. Thank you for sticking with us, and I'll hand it over to Jenny.